my brother, they
Okay, good morning everyone, and welcome. We're glad to see the turnout we have here. I'm Ken Schrader. I'm the local Portage County agricultural agent working for UW Extension, so glad to see you turned out. We've been working and pulling together a good informative program for you today, and so we'll have some presentations. This morning we have two folks from UW-Madison are going to talk, and then we'll have lunch provided by the Biadasz Safety Fund. I stand corrected, it's part of that program, but the lunch sponsors are Hub, United FCS, and all of them are here? Rural Mutual and American Family Insurance. So if you work with any of those folks, be sure to reach out and thank them for their generous donation, providing us with some food today for the program. So with that, I'm going to turn it over to our first speaker, Becky Larson. And she's an associate professor at UW-Madison. She works in the biological systems engineering program, and she's done a little bit of work with manure and manure gases, and she's going to tell us a little bit about how they're generated and provide us some details on that. She's also done some extensive work with manure irrigation. She spent a good chunk of time working on that project, and they pulled together. She worked with a group to evaluate the what's happening when we're irrigating manure. So, but that's not the topic for today. Today is manure gases. So welcome, Becky Larson.
Just for the camera. All right, I'll use both. Here, okay. Hope I can keep everything. My name is Becky Larson. I am an assistant professor in the biological systems engineering department. I work all in manure all the time, so I smell good constantly. I'm here today to talk a little bit about manure gas production and dispersion. I'm also an extension specialist, so you might see me around in the state talking about some things related to manure. As I go through this, please feel free to ask questions. I hate feeling like I'm just lecturing people, so if there's something else you want to know that's not in the slide that you don't talk about, feel free to reach out. I'd rather give you information that you care about instead of whatever I might have talked for originally. Okay, so I'm sure most of you here have seen a manure storage. Know that it's there, there's purposes we have it, right? It's really great in terms of allowing us to increase our timing of application. It stores manure, it helps us reduce a lot of our environmental impacts when we're applying. It helps us tailor our applications to be a little bit more conducive to crop growth. And then it also can help us with some labor and activities of reducing and improving our efficiencies. But manure storages also have some issues in that they release gases, right? Gases produced in manure storages are released all the time, right? So it's always producing gas and they're always being released. So in the case of like the manure storage you see here, there's different conditions, right, that promote certain kinds of gases to be produced. Manure storages, which are liquid or slurry in nature, are anaerobic, which means they have no oxygen within the system. So the microorganisms that are naturally in your gut or the animal's gut, right, break down all of the organic material and release gases. It's a natural process. It occurs places other than just in manure storages, right? These kinds of things happen anywhere you have anaerobic soils and that you have organic matter that can be broken down and you're then releasing some of the things within there. So it's happening all the time. And the major gases that people that you see being produced during this process are methane, carbon dioxide, ammonia, and hydrogen sulfide. Now there are other gases depending upon the characteristics of your manure, but I would say in terms of health and safety, these are the ones that are concerning to you, and they're all concerning for different reasons, right? Ammonia and hydrogen sulfide have toxicity issues. That means at really even low concentrations, they can cause many issues. And then the methane and carbon dioxide are different, and that they can, if you have too much of them, they become an asphyxiant, right? That you don't have enough oxygen present for you to breathe. So normally these gases are produced. The reason we have lots of manure storages, the reason we don't see a lot of problems everywhere is that normally in many conditions, the gases are produced slowly and then they release and are dispersed at concentrations that are not dangerous, acutely dangerous to our health, right? So when I say acutely dangerous, I mean concentrations that immediately cause acute health concerns, okay? Sometimes there could be long-term impacts. We know some of what the long-term impacts are, what concentrations. We don't always know what the long-term impacts might be of repeated exposures, etc. So there's lots of standards that help us understand when these gases become acutely toxic. And a lot of these standards are developed in terms to keep us safe for, like right now, if a gas came in and I breathe it in, and it might cause something like a headache, right? So they've determined concentrations that cause different problems, and they make these standards based on that. There are a lot of places that make different standards, okay? So you're gonna see different standards out there. The ones commonly that we'll refer to are things like OSHA, right? Occupational Safety and Health Association puts out standards, but there are many other places that also put out standards, right? That could be a little more stringent than this or could be a little more lax. I'm gonna talk today about the OSHA levels because I think these are some key ones to be careful of when we're talking about manure gases, right? So in ammonia, we have this 50 ppm, which is an 8-hour time-weighted average. Now the reason I use these terms is because they're common in health and safety, so if later you want to go and Google something, these are the kind of terms that you're going to see, right? So what does the 8-hour time-weighted average mean, right? That's the concentration over an 8-hour work period, right? That may cause problems if you exceed that level on average, okay? So then we also have something called an acceptable ceiling concentration, right? Here is the maximum concentration you want to be exposed to, right, when at any one given moment, right? So this isn't a long-term exposure. This is a ceiling that you would never want to pass. And then we have other things that will give you peak ceiling concentrations, maybe for a certain time period, right? Because these are talking about acute exposures now and not concerning like long-term effects of repeated exposures that you're looking at in the 8-hour time-weighted average. So you'll see that carbon dioxide, it does have an 8-hour time-weighted average. I don't have methane up here because methane and carbon dioxide, again, the primary concern is that you get too much of those gases produced and you don't have enough oxygen, right? So you want to maintain that there's enough oxygen for you to breathe and be safe. The other two, ammonia and hydrogen sulfide, have toxic effects at low concentrations, right? So I'm going to go through those in a little more detail. Hydrogen sulfide is probably the main gas of concern. When we've looked at incidents and actually have hard data on what has happened, hydrogen sulfide is the main problem when causing health issues. I want you to understand this is the biggest concern that I have for people when you're working with manure. It's the biggest concern I have for my students when they're in the lab. It's the biggest concern I have for them when they're out in the field, and for the people like you that are working in these situations. Okay? So I am careful of this even when I work. Now the things that you need to know about hydrogen sulfide is typically in background concentrations, it's very small, right? So when we say part per million, right, this is a tiny amount in this huge amount of gas you might be breathing in. It's a tiny fraction, right? So your typical background level is very, very low. And then you start to be able to smell this at a ppm, that's part per million concentration, at 0.001 to 0.008. That's very little, right? Have you ever smelled hydrogen sulfide before? What does that smell like? Rotten eggs, right? So is that a good indicator of when you might be in danger? Initially, maybe, you can smell it. The big problem with that is, as you start to increase the concentration, 0.3, you might start to get a headache, you might not feel very well. You start to get a really offensive odor from 3 to 5. You start to, in that range, if you have asthma or other things that might compromise your respiratory system, you might start to have issues. You start to get up to about 150, and no longer, it says the olfactory paralysis, right? That means the things that help you smell become paralyzed. So no longer can you smell that odor anymore. So a lot of people think in their heads that might be a time to say that the problem is gone, I can't smell it anymore, I don't have a health issue. I would never use odor to be an indicator of something dangerous, okay? Because now you can't smell, you think it's gone away, but now you're approaching levels that start to have some very serious consequences, right? So that should be a trigger warning. You smell it, starts to get strong, you should be aware of that, but don't think because it goes away that then you're safe, right? It's important you can use your senses, right? They're important to trigger some reaction in us, but don't trust that because it goes away that you're now safe, right? And you get up to these kinds of concentrations, and they have very serious consequences, right? We're moving towards loss of consciousness, death, and even if, you know, some of those situations can then lead to death, even if it's not immediate. Okay, ammonia is also toxic, all right? Detectable odor for ammonia is maybe around 0.04 to 0.5, so very small. So I'm sure you've all smelled ammonia, particularly if I'm in like a poultry facility where the ventilation isn't very good. I can really get a strong sense of ammonia. When it gets really strong, you can feel it when your eyes water, right? You're getting some pretty serious, you're getting up to maybe 50 or 100 when you start to feel those eyes and nose irritations. And then you start to get a cough and you get some airway dysfunction, but we're still around 150 ppm. Now long term, there may be some impacts from breathing ammonia at those concentrations repeatedly, but for acute situations, you don't get to something that's dangerous to your life until you get upwards of 2000 ppm. Now, in all of the research that I've done and that I've seen, we have not seen a report from a situation where a manure system resulted in ammonia concentrations that were that high. Right? Even when we apply manure out in the field, the ammonia concentrations we have in the air off of the field are well below 100 ppm. Right? So you may feel some irritation. Irritation is probably not necessarily a great thing, but that's not necessarily going to mean that it's dangerous to your health at that moment. So this is why I go back to, if you can ensure that you have enough oxygen, that methane and carbon dioxide displacing that amount of oxygen, then your main concern from manure systems is going to be that hydrogen sulfide, right? That is going to be your primary concern. I do want to mention there are lots of the other incidents that have led to very tragic incidents related to ammonia have been from other sources of ammonia on the farm. So while I'm going to make a little plug that I'm a manure specialist, again, remember there are other circumstances which could produce gases that are high enough that could be toxic. Okay, so, you know, all the time manure is being produced from or gases are being produced from a manure storage and being released. Now we move to the time period when we're trying to empty a manure pit and we go to agitation, right? Agitation is important for a lot of reasons in terms of how we apply manure to the land, even operationally and emptying your storage, right? There's a lot of reasons we do it, but what happens then when the agitation occurs? All of the gases that have been being produced are released out of the surface of the storage, but what can happen is based on the high amount of solids within the liquids, gas bubbles, right, little tiny ones, are like evenly and dispersed all around in that storage.
Not even necessarily super evenly, but generally there's probably a lot of gases, little bubbles trapped all in that manure storage. So what happens when I start agitating, right? You can think of all of those gases, much more than normally is being released, are all moving up to the surface at once, right? That's when we see major gas concentrations increase. We're causing this release. Now, some people will say, all right, well then right when I first start agitating, that's my biggest concern. But how big of a pit are we talking about, right? When you're agitating, do you just agitate for 10 minutes because that's the little area? No, right? You're usually moving your agitators around. You're disturbing new manure that has gas trapped within it. So there's always a chance when you're agitating that you're increasing the gas levels that are being produced into the air that you're breathing around you, right? I hope that all makes sense. Okay, so you can see there's different types of things. One of the pictures, we've been working on a fact sheet, and I was hoping to have that done for you today when we had this event, but we'll provide you the information with it shortly. It should be produced shortly. Is we were looking at some pictures, and one of my colleagues said, oh, look at this spray, right? This spray, that's a concern for me. What you visualize is not, again, the concentrations, right? Spraying does not necessarily mean that your gas concentrations are going to get, that's not a good indicator, right? If you're not producing any spray, that does not mean that your concentrations of gas will be low, right? So while I want to show this because I think you know, you can see a little bit of what's happening in the agitation process, these kinds of indicators are not good indicators of if you're experiencing dangerous levels on that, right? So you need to be very aware that while your senses are useful, you can't trust them in terms of gas concentrations. Okay, so gases are produced. Maybe a lot of you already knew that. They're leaving the gas storage. Now, there are certain situations where we increase the production of some of these gases, right? And so we'd want to try to avoid those. Number one, like this one we can avoid, right? Increased gas production occurs when we have higher temperatures, right? So I'm going to go to this slide here and show you. This is, somebody was looking at the temperature impacts, and there's citations down there if somebody wants to look at this later. But you can see as temperature increases past about 18 degrees Celsius, which is about 64 degrees Fahrenheit, you start to see the hydrogen sulfide concentration increasing dramatically in production, right? The temperatures increase gas production because those microorganisms that exist in the manure, they become more active as you increase their temperature, right? So they're degrading faster and they're producing more gases. So as you increase, you're just going to continue to go upwards and upwards and upwards of those hydrogen sulfide concentrations, right? So look at the temperature, so it's 73 degrees out. Your manure storage might be warm. What are we, August, September? Maybe I'm warm at that period. Now all of a sudden, I'm upwards of 1,000 ppm of the hydrogen sulfide concentration. Where did that land in my toxicity progression? That was in the levels that were deadly, right? I mean, over 500, those levels of gases are deadly, right? So you need to be careful that these kinds of things increase hydrogen sulfide production. Now, do you think at 13 degrees Celsius that I can assume that that the concentrations are going to be safe? I would say your risk is reduced, but you cannot assume that those conditions are going to ensure that hydrogen sulfide is not at a concentration that might cause you issues, right? Because you could have trapped a lot of gases back a little ways ago when it was warm, right? Think of that first picture I showed with the cover. That natural crust that occurs in manure storages are great to keep down odors and other things, and it can reduce some emissions, but it also can trap some gases even more so than if you had a more liquid manure slurry, right? So even if you were cooler, if you're now at this time, it may have been warmer before or gases may have been trapped in there and still have hydrogen sulfide levels that are high enough to be toxic. Okay, another issue is decreasing in dispersion, right? Dispersion is the thing that reduces those concentrations and keeps them at levels that are not toxic to us, right? So they're produced, you know, in this little area I might have 1,000 ppm, but then when I increase it into, disperse it into like a space 1,000 times, now I'm at 1 ppm, right? So I've really reduced the impact of that. That is the biggest reason that we don't have toxic gases everywhere, right? We disperse them, the concentrations go down. So there's some things, your distance from the source, right, has more time to disperse, more air volume to disperse into, right? So the closer you are, generally the higher the concentrations you have. If the conditions are still, or there's something that prohibits dispersion, right? You can think very simply like a barn, walls, a confined space is a key thing of why they say confined spaces are so dangerous, is because you've enclosed the gases so they can't disperse, making sure those concentrations are really high, right? The natural cost, any covers, once you disturb that cover and remove it, then all of a sudden you're going to release that. So those reduce dispersion over time, and so you're going to get more gas release at one instant when you agitate. The last thing I want to mention is hydrogen sulfide levels. So our sulfur levels, right? Hydrogen sulfide is pretty simple. The more sulfur you have in your manure, the more hydrogen sulfide you're going to get, right? Just kind of similar to that temperature increase, we see the same thing with sulfur. You add sulfur, you're going to increase hydrogen sulfide production. Can you think of anything that has sulfur in it? Yeah, there's a lot of different chemicals you might use. Some of those are in, you use so little of them that it's probably not increasing the total sulfur content of your manure storage. In Penn State, they did a lot of work on gypsum because people were adding that to some bedding. Gypsum has a lot of sulfur in it. I don't know how many people are feeding things like distiller's grain. That's become very common. Distiller's grains has a lot of sulfur in it, particularly because they use sulfuric acid as a cleaning stage, right? So that increases their sulfur content. And so that can be a big issue. And in the fact sheet, I have some hard numbers of recommended percentages for your diet and what the normal sulfur range is in your manure. And it's quite low. It's only a few pounds per 1,000 gallons. And if you find that your manure levels are much higher than that, when you're running a typical manure analysis will give you sulfur levels, right? If you send your manure sample away, that's one of like the 4 or 5 things they normally test for. If your concentrations are much higher than that, you need to know your risk is much higher in producing the sulfur. I just want to give you some images of what I'm talking about with dispersion, right? If I have an open manure storage, the highest concentrations are going to be down by the surface, right? Or if I'm agitating, I'm going to produce these highest concentrations, and as I move away, they're dispersing, right? So the biggest thing, the reasons we see such issues is if I put a barn wall there or something else, right? And you can see that I have wind up here. Right? Wind causes the gases to move and gives them more volume to disperse in. That's a great thing. If we're very still, the gases don't move and you get more buildup because they're not dispersing as you normally would. Now, can I put a number on the amount of the wind speed you need to make your risk 0? No. So I will tell you, if it's windy, I would prefer to be out and agitating when it's windy than when I have no wind. But the differences in wind, and even if you can feel wind, the measurements are extremely difficult to make. So when we were doing our manure irrigation work, we had to measure the wind speed because it had a big impact on how far downwind things moved. But when we're really out in a field, the winds can change like that, right? And it made that particular project very tough because the wind would move at 15 miles an hour and then it would change direction and then it would stop. So winds are actually, they're all over the place, and locally, normally most of us don't have some kind of advanced weather system to be telling us what those wind numbers are. So I wouldn't take that you think it's windy enough, that's no risk. But generally you can say the more wind you have, the less risk you're going to have when you're agitating, right? But I'll always recommend monitoring.
You might get to this, but does atmospheric pressure play into it as well?
There's a lot of things that can play, and unfortunately, there are so many environmental factors, we can't always say how they play off each other too, right? So the things that happen, so there's a lot of atmospheric things that happen that can create some layers, but those layers are so big that pressures and stillness and these periods of inversion can reduce dispersion at a pretty high level, right? It's not reducing dispersion, like there's not a layer right a foot above the ground, right? But these kinds of situations can make it so air is just not moving and dispersing normally. So then you start to get concentrations building up around the storage. And the impacts are complicated and difficult to measure. And so that's why I always say, increased wind is a good thing. I'd rather be agitating, your risk is less, but monitoring is the only thing that's really going to tell you really what the concentrations of hydrogen sulfide are. Okay, in addition to maybe outside storages, my biggest concern usually is when we have barns with manure underneath. I went to a producer who called me after their barn exploded, I don't know how many times, right? So you can build up gases underneath in that, like if you have an under barn storage, you get a lot of gas buildup within there, right? You have limited dispersion in those situations significantly. And then you have gas buildup inside the barn itself, right? So number one, if you have an area where you store manure, even if you've pumped it completely down, or a tanker or something, you cannot go into that situation. You have limited anything from dispersing there. I've been with a lot of producers who tell me, well, I've done it 100 times. Well, the 101 time might be the time that you get into trouble, right? So you need to be careful. You need, and just because you've been in a situation where it happened to disperse doesn't mean next time it will. So when you're in those kinds of areas, you need to follow confined space training, and John will probably touch a little more on that. But in general, when you have a barn above a manure storage, I recommend everybody being out of the barn, all of the animals being out of the barn when you agitate. Again, those gases are going to get released, and then you don't even have the open space of a normal manure storage where we know issues can happen. And I've seen many more issues in these kinds of circumstances where you're kind of limiting the movement of gas. I wanted to put a little bit, so this is a little bit about the work that they looked at Penn State. You can see they were monitoring outside some manure storages while they were agitating. And you can see the concentration on the left-hand side. The different lines represent different farms and different circumstances. Some had gypsum in them, some did not. Obviously, the gypsum farms are some of the ones that you see bouncing higher. More sulfur is within those things. What levels are those reaching? Up here, we're upwards of 400, 500 ppm. And what we talk about is 500 ppm was the top limit of their measuring systems. And already you've hit levels that are toxic, right? So you need to be aware that, number one, the sulfur in the manure drives these production of these gases pretty seriously. And two, look how quickly, these are in minutes, right? 0, 10, 20, 30. Look at time 20. Look how quickly that concentration increases, right? This can happen very quickly. You need to be prepared. Your monitoring systems will alert you, and John will talk more about that. But when you hear them go off, you need to move quickly away because the concentrations fluctuate at any given time. So the sulfur content in manure, here's a few numbers for you. You can think any animal, if you have excess sulfur in their diet, that's going to be excreted in the manure, right? So anything that you have in excess that a cow doesn't use or an animal doesn't use, it gets excreted in the manure, right? So if you increase the sulfur content, again, increase H2S production. For cattle manure, liquid and slurry, we've taken over 22,000 samples. This is over a 10-year period. The median total sulfur per 1,000 gallons was 0.6 to 3.2 pounds per 1,000 gallons, right? We saw values in there where people were finding 450 pounds per 1,000 gallons. I have a feeling that was hitting some kind of maximum of our threshold, right? So look how much higher that is than what we're talking, the average numbers. There are situations where you're feeding something that has too much sulfur. Number one, you can hit toxicity in your animals, but then there's other ways to combat that you start feeding other things and to overcome the issues with your animals, but then you still have the sulfur being excreted in the manure, right? So it is very important, if you look at a manure analysis, make sure you're not super far on the end past these median values, or you may be reaching high-risk situations. Okay, that's all I have. I don't know if you have any questions. All right, then I'll let John move to the next part. All right.
Got a question for you. And have you had any experience with manure additives and how they could affect the hydrogen sulfide gas generation?
Sure. So there's some manure additives that actually can reduce hydrogen sulfide production. Iron, anything with iron, like sometimes they say ferric chloride, you can add that and it'll bind sulfur and precipitate it, so it'll reduce your hydrogen sulfide. The idea that you'd add something like that to your home manure storage would be very costly, right? They add things like those kind of products to digesters to reduce their hydrogen sulfide, because at those levels not only does it become toxic, but it's very corrosive and destroys equipment. So there are ways to combat hydrogen sulfide production with additives, but the cost of that would be very prohibitive. Because if you think about it, the majority of things that reduce hydrogen sulfide production are binding sulfur. And the idea that you could bind all of the sulfur in that huge content of manure, and these additives are going to bind other things within there, you'd have to add so much that it would be an astronomical cost to you. So I would say, instead of doing that, buy the monitoring equipment. It's much cheaper. It'll reduce your risk significantly. And then you don't have to run into those. There are some other additives that say that you can reduce. So there are ways to inhibit the microorganisms that produce hydrogen sulfide. So they're called sulfur-reducing bacteria. But the animal's gut produces sulfur-reducing bacteria constantly. So you'd, again, have to keep adding this kind of additive. And I don't know that in a manure storage you could effectively try to control those. We try to do it in digesters and have been completely unsuccessful. And there's a bigger economic payback, right? Where in this case, it's just out of your pocket, and the reason you'd be doing it is for safety. And so I'd recommend, aside from any additives, stick with the monitoring equipment.
Okay, any other questions for Becky?
Yeah.
Becky, when you were going through the temperatures, that was the temperature of the manure slurry and
Yes.
not the outside
Yes,
temperature?
that's correct. That's correct.